Thank you for reminding me. All right. Example 1, we're going to write the prime factorization for the number 48. Ooh, I know you've done prime factorization before, so it should be a review. So raise a hand, does anyone remember how to do the prime factorization? Or how to at least start? Emily. Factor tree, that's how we start. And we've done factor trees before already, Annabelle. Let me take that. I want to see it every day. Okay, factor tree. So Annabelle, what two numbers multiply to 48? Factors. There's lots of options. So this is even, so that's 1/10. So we can find it. Yep, that works. Sure. You could have also done 12 times 4, 6 times 8, right? So there's other options, but they'll all eventually get you to the same result. Okay, 24 breaks down, Zach, into what?
12 times 2.
12 times 2. 12 breaks down, Jada, into what?
6 times 2.
Yep, 6 times 2. And 6 we know breaks down into 2 times 3. Now all of these that I've circled are primes. That's why we call it prime factorization. So we found the primes. Now let's write it in prime factorization. Anyone remember what that looks like? Justice?
Like 2 times 2 times 2 and 2 times 3.
Okay, that would be the expanded form. And then now we're going to write a prime factorization, which means we condense them. How many 2's were there? 4. And we do start with the smallest base, which 2 is the smallest base. 2 to the 4 times, there's only 1 3. So times 3. Yep, that's prime factorization. Okay, with an eligible partner, I would like you guys to do the prime factorization, please, for negative 72. With an eligible partner, work out prime factorization with an eligible partner for negative 72. That's why you have a neighbor. Talk to your neighbor about it.
Can you like negative 8? Oh.
Talk to your neighbor about it, please.
Negative 8 and 9, right? Is that what?
Talk to your neighbor about it. Example 2.
And then negative 8 is negative 2, 4.
So showing you how to do prime factorization in example 1. Now with your neighbor, you guys can talk about it. How do you do example 2?
I think that's right.
Similar to how we did example 1.
I got
Negative 1.
Close. Okay, you're warm. There's just one detail that's tricky for everyone. I'm waiting for someone to find it for me.
Oh, come on, you gotta answer. I'm close. She said you I thought you were close.
I haven't seen a perfect one yet. There's been some that are close.
No, wait, no, it's going to be negative 2.
Okay, well, here we go. Have everyone's attention please in 5, 4, 3, 2, 1. Uh-oh, 4 is being weird again. How do we break down negative 72?
Negative 8 and 9.
Okay, so there's lots of options. 8 and 9 I heard. But 8 and 9 would be positive 72. So would another factor be negative 1? Negative 1 is a factor, right? Because all of these that we've circled have to multiply back to the original number. So in the last problem, 2 times 2 is 4, times 2 is 8, times 2 is 16. If you multiply that by 2, we get 48. So we have to have this -1 so it multiplies back. And we know an 8, remember the shortcut for 8 is 3 2s. And then 9 is 2 sets of 3. If we multiplied all those back together, we would have -72. Okay, so the prime factorization, which base is the smallest? A 2, a 3, or a -1? -1. So it's -1 times 2 cubed times 3 squared. So the bases do have an order to them. It goes smallest to largest. -1 is the smallest base, 2 is the second smallest, 3 is the largest. So there's an order. So there's a handful of us that got close, we just pull up the -1. Okay, with your partner again, you guys should actually be talking about math. Try example 3.
This is method.
We're on to questions later. Okay, would you guys send this way?
Serious?
Yeah, partner up across here too. Make sure, obviously, let's fuck it up. So you have partners. You guys are not find a different partner. Go forward or backwards to find a partner who can help you. Okay, you have to start. Go together. You have to start. Go to see you. Oh, yeah. So then, you one.
No, not -6.
Hey. You should find a partner. Or this way. You're stuck. No. You always have to go to this guy. Find a new partner, he can find a new partner. Okay. Everyone attention up here, please. Okay, eyes up here. Specifically, Johnny Green. You left your question, Johnny. This is yours. To make it hard to do your homework. Did you leave this last time? Okay, Johnny. Let's just pretend that the x's and the y's aren't there. Let's just pretend it's -36. Johnny, how would we go about breaking down -36?
Same thing. Yeah, the -1.
We pull out a -1, and then?
6 times 6.
And then 2 6s. Good. Okay, it was Osley? Osley, okay? How did the 6s break down? 3 times 2. Okay, now with the x's and the y's, do we actually need to break them down?
No, you just add them.
You just add them on, because at the end, we're just going to put them right back together. So breaking x squared into x times x is just extra work, because in our answer, we write it as x squared. Okay? So, our prime factorization in order of lowest base to highest base. -1 is first, times 2 squared, because there are 2 2's, times, good, times X squared, Y. So those were going alphabetical order. So we had a couple figured out. Good job. A couple were close. Good job.
So we don't do anything with the variables?
No, because like these guys, once we know how many they are, put them back together. So x squared, the squared already tells us there's 2. So no need to break them down because we just put them right back together. Well, it has to multiply. It has to multiply to 36. Right? So this is not what we're doing. I'll do it over here. Negative 36, we don't break down into... Okay, it would be so great if you weren't talking all the time. Six times negative 6 is still negative 36, correct? And if we break down this 6, we have 2 and 3. Break down this 6, we have either 2 and negative 3 or negative 2 and positive 3. But then when we do our exponents, right now I only have 2's that are together, and these are now different. So that's why I just pull out the negative 1 so that they can be the same. So that way we have the same there, and then we can pull out a negative 1 up front. Okay? So down below there's a chart. I'm going to use the mouse because it's not like my finger today. Fill in the following table with no calculators. I want you to fill in the first 2 columns, 1 squared to 12 squared. Remember, the square means 12 squared is 12 times 12. 5 squared is 5 times 5. Without a calculator, please fill in the columns. 1 squared all the way through 12 squared, the first 2 columns. Good. Almost there. We're going to do kind of like a choral response when we're ready. Your whole row together is going to tell me the answers to the one I give you. In just a minute. Okay, starting with those back 5 on the left. Okay, at the same time, I'm going to ask you what 1 squared is, and at the same time, you're going to respond. Okay? Ready? What is 1 squared?
3.
What?
1.
1 squared is? Ready?
1.
Okay. Next row, a little more enthusiastic than that. Third row, you 4 ladies. 2 squared is?
3. No, well, 4.
Guys. I'm trying to show you off. 2 squared is? 4. Okay. Please get better. Okay, 3 squared. Can you beat them? Because we've been struggling a little bit. 3 squared is? 9. There we go. First row, 4 squared? 16. Okay. Well, the enthusiasm, you 3. 5 squared is? Thank you. Neighbors, again, everyone. 5 squared? Wow, this is, maybe I didn't explain this very well. We're kind of struggling here. Okay, you know the directions. When I go like this, that means you all respond at the same time. Okay, 6 squared is? Oh, finally, thank you. Okay, 7 squared? Oh, wow, it got worse. Okay, 8 squared back row? Okay, I have to say these 4 ones. They get the gold star. Okay, 9 squared. 9 squared for oh,
81.
9 squared random person?
81.
Veronica. 81. Next, random person? Aria, 10 squared. Okay. Random person? Lee, 11 squared. Yeah, so what I would do there, if you don't remember, so 10 times 11, because the 10s are nice, so all we do is add a 0. 10 times 11 is 110. And then you just add 11 more, and you get 121. Okay, 12 squared. Tony. There you go. Okay, if you don't know some of these, you need to start memorizing them. We use them a lot. Now, on the right-hand side, there's those two columns. This is the inverse of squaring. Just like adding has an inverse, multiplying has an inverse, so does squaring. If I add $4 to undo that, I would take away, or what's the mathematical operation? Subtract. If I multiply something to you, what's the inverse of multiplying? To undo that. What's the inverse of multiplying? Division, divide. Okay. Well, with squaring has an inverse. To undo squaring, which gets it larger, to undo that, be square root. And it brings it back down. So the square root of 1 is 1, because 1 times 1 is 1. We have a pair. Square root of 4 is 2, because 2 times 2. And if you notice, these quickly just change into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Yep.
Because we're just undoing what we did on the left-hand side. Okay, simplifying radicals. We've talked about radicals. We start with prime factorization like we have above, and then we look for, based off the index, we look for pairs or triples or quadruples, depending on what the index is, to pull out. Okay, so for example, 4, I need two numbers to break down 24, so we can get the primes to see what pulls out. Wait. I'm working on names. Let me work on names. Brooklyn. Give me 2 factors of 24. 12 and 2. Someone said 8 and 3. Does 12 and 2 still work though? Okay, yeah, 6 and 4 would work. And 12 breaks down into 6 times 2, and 6 breaks down into 2 and 3. Okay? But unlike prime factorization, we don't put them back with exponents. It's actually nicer to see them expanded out. We worked on this last week. How many 2's were there? There were 3. But before we find our groups, you have to look at the index. Fingers in the air, what is the index for this radical? Fingers in the air, what is the index? We talked about that vocabulary word index a couple of classes ago. Index. If it's not there, there's only one that it could be. It is 2. That's why we call this the square root, because the number 2 is squared. I saw a 1 on your finger. Was there a hidden finger behind it?
Yeah.
Okay. If it's not written, it is automatically a 2. So that's something you should know. We're looking for then pairs of numbers. Okay, so I have one pair of 2's that pulls out. Does anything else pull out? Can I put these 2 together? I can't put those together. Does it become 5? No. 2 and 3 becomes 6. So simplified, you don't leave as 2 times 3. You times them back together. Just as a reminder, make sure you are jump on the notes, because we do turn in notes for points on the day of the test. Okay? So example 5, we're going to break it down and see what we can pull out. 128 is a little larger. Anyone help us find 2 factors for 128? Does it work? 32 and 4, let's see. 12 divided by 2 times 4, 8. 4 times 3 is 12. Yep, that would work. You could also do 2 times 114, or 2 times 64. Okay, break down all the way to the primes. Right now, on your own, break it down all the way to the primes. breaking it down all the way to the primes. Okay, Brayden, what did you get for all of your primes? What are all the primes of 128 when you broke it down? The numbers I normally circle?
Wait, just make sure, is that a 32?
Yeah, this is a 32, and that's a 4.
Okay, I went down and like, on the 4 was 2 and 2,
Okay?
and then I went 8 and 4, and then broke down the 8 and the 4 too. So like,
How many 2s did that end up being? So that's a lot.
that's
7 2s. So 1, 2, 3, 4, 5, 6, 7. I'm going to have to put these x's underneath because I ran out of room. Don't forget, there are actually 2 x's there as well, right? Is x squared? And then 1 y. Fingers in the air, what's the size of our group we're looking for to pull out of the radical when we're simplifying? Fingers in the air, what's the size of the group? Specifically, Hunter, I love it if you put your fingers in the air for how many we should pull out. Hunter? One, will you poke him? Almost the weekend. You're gonna make it. Okay, fingers in the air. I only see a few people responding. What's our group size this time? Great, thank you.
God, I got it right.
So, Jada, how many groups of 2s can I find? How many groups? So like that's 1 group.
Oh, 3.
So 3 groups. So there were 7. Is that the only thing that's going to pull out? Do we have anything else that could pull out? The x's, yes. So when we pull out, I pulled out 3 groups of 2. So does that make it negative 2,222?
Whoa.
No, we times whatever we pull out. And the only thing that doesn't pull out is a 2 and a y. So, shout it out. What is negative 2 times 2?
4.
Negative 4 times 2. Negative 8 times 2. Negative 16x root 2y. Please try example 6 with your neighbor. Now you've seen how we do it with both integers and variables underneath. Please simplify example 6. Okay, the short schedule has put us behind schedule. So, let me go over really quick, make sure it's good to go, because we have a couple examples on the bottom we need to do. Once again, we'll start calling pairs. Okay, the 27 breaks down into 3 and 9, and the 9 breaks down into 3 and 3. Since it's a square root, we're looking for pairs. So I have a pair of 3s. I'm kind of running out of room, so I'll try to put them out here, I guess. 3, 3, 3, 2 A's, 4 B's. So when I'm writing on the board, that's not time to start doodling. I have a pair of 3s, we have a pair of A's, we have 2 sets of B's, right? So when we pull out, we have negative 2 times the 3, and an A pulls out and 2 B's. Is it okay if I write the 2 B's as B squared? Yeah, that's even better, actually. Root 3C. So don't leave any multiplication that could be simplified undone. I'm going to times those together and get negative 6A B squared root 3C. Okay, down below. Somebody's in the back side. There's a problem I wanted to do. If you could flip to the back, where it's blank, we're going to add a problem on the back. We're going to add this one that I have. Of course, SmartWork's not working. Let me come click on it. We're going to add the one that says example 10. Please add example 10. Example 10 says that's a cube root. I'll write it bigger just to make sure everyone can see it. I really think it's just that corner. This side. Awesome. Thank you. I really think it's just that corner. Okay, same directions as the last one, so we're simplifying. So here's where that negative comes into play again. Raise a hand, who can tell me how to simplify the negative 16, breaking it down? Queenie. Negative 1 and? Give me 2 more. What else would multiply to negative 16? Negative 1 times 2 times 8. Okay, there we go. So yes, you caught that negative 1. Negative 2 is a prime. 8 breaks down into 3 2s. So, notice the index. This time, we don't want a grouping of 2. We want a grouping of what? 3's because of the index. It's a cube root right here. So I find my group of 2's. And I find my group of 8's. I was going to say, I think they're supposed to be cell underneath. What am I doing now? Okay, better? Let me ask you a question, though. Will these also be equivalent? If I left these underneath, will this also multiply to negative 16? Negative times negative is a positive, times the negative is a negative. So it would be negative 16. I would prefer you to do it this way because then the negative pulls through. Then I have my group of negative 2's and I have my group of A's. So the answer would be negative 2 root, there's an A there, 2. Okay? So play with the negative, see if you can make it into something that would pull out. The homework, which next time we'll have questions on and will be due on Thursday, is this worksheet. Okay, it's already hole punched, so it can go right into your binders for you. This worksheet we'll do questions on, but page 48, Ms. Grace talking, you should probably stop what you're doing and listen. Okay, I'll wait for you. It would probably be good if you stopped what you were doing and you were listening. Page 48 is due next class. If you still have questions on page 48, please see me after school. This worksheet will have answer some quick questions next time. But next time, remember, we're in the computer lab across the hall.
With Jonathan Perez.